So I have written here what we have to do to begin with. Factor the expressions. So for 2x squared minus 8, I know I have a common factor of 2, so I will take it out, and then x squared minus 4. But my x squared minus 4 is still factorable using difference of two squares, so I'm going to factor that using difference of two squares. X plus 2 and then x minus 2. And then over x squared minus 1, another difference of two squares, so factorable as x plus 1, x minus 1. And then times x squared plus 2x plus 1. If I have to factor that, that's x plus 1 times x plus 1. Then my denominator, I have a common factor of x. I'm going to begin with that. And I'll get x squared minus x minus 2, which if I examine this factor, this is still something I can factor using product of negative 2 and sum of negative 1. So let me just write another factor here for x minus 2 and x plus 1. So that is factoring this out again, or factoring these expressions again. So all of my expressions had been factored. Then I'm going to go to the second part. Divide out common factors. So what I do find out that I have in common, I have here a pair of x plus 1 and x plus 1. Another x plus 1 by this x plus 1. X minus 2 by this x minus 2. So what I'm left with here, I have 2 and x plus 2 on the denominator, and x minus 1 and x at the denominator, and I'm just going to write them out as my factors. So 2 times x plus 2 over x times x minus 1. So that's the simplified form. I can still multiply them, but I rather have it in this factored format. Then let's look at the restrictions. What x value I can't have. So x cannot be. Let me begin with this value. So if I plug in what value, I'll get 0 for this. So negative 1. Then let me get the value for x. That will be 0. And then for x minus 1, that will be 1. And for the x minus 2, that will be equal to 2. So these are all the restrictions on x that I can have, because if I do use them for this expression, I'm going to end up with undefined. Okay, let's look at item number 2. So this one is the division of rational expressions, which is like multiplication. We need to begin with this factoring the expressions. But before I do that, since this is division, I'm going to look at like the division rule of fractions is I have this change into multiplication, and I have this change to its reciprocal. So let me rewrite the problem. X squared plus 5x plus 6 over x squared minus 4, and I am changing the division to multiplication, and then 3x squared minus 4x minus 4 over 5x plus 15. And this is where I'm going to go ahead and do the factoring the expressions. So what are my factors? I have x plus 3, x plus 2 for the first part of my numerator, and then for my denominator, x plus 2, x minus 2, difference of two squares, so this, and then times, I'm going to leave out my numerator and jump into the denominator because my denominator is easier. I have a common factor of 5, so that will give me x plus 3. Now for this one, my strategy is I will change the problem as x squared. So let me do it over here. I'm going to change my problem into x squared minus 4x minus 12, because this is easier to factor. How did I get to this? I simply take this 3 and multiply it by -4. And I'm going to work on factoring this given expression. So my factors are x minus 6 and x plus 2. But these are not my actual factors for these expressions. So I'm going to be needing this 3 again here and use it as my divisor. And if I can, I will simplify my answer. So first part, I can simplify to x minus 2. But the second part, I cannot. So what I will just do is multiply this 3 into that x. And this is 3x plus 2 as my factors of 3x squared minus 4x minus 4. If you want to check, multiply them and you will be getting this product. Okay, so let me use these factors now. So x minus 2 and then 3x plus 2. And just like what we did in the multiplication, we're going to divide out common factors. So whatever we have from the numerator and denominator, which are same factors, we're going to cancel them out. So what I can cancel out, a pair of x plus 2 and x plus 2, an x plus 3 and an x plus 3. What else do I have? I got x minus 2 and x minus 2. And what am I left with? I'm left with 3x plus 2 on the numerator and 5 at the denominator. Now, it's not because I only have 5 at the denominator, I wouldn't have any restriction. I still do have restriction because restriction is from the original question. So over here, I was able to factor this out as x plus 2 and x minus 2. So what value that will make the 0? I'll get -2 and +2. Now, this denominator was originally a numerator, but if it happens that my numerator here turns to be 0, 0 divided by something is 0, making my division undefined. So I still need to consider this. I can't have a -3 as well. And then on this part, I had this as my original denominator. So if I'm going to make this part 0, that will make this also undefined. So for 3x plus 2, I cannot have a -2/3 for the value. And those are my restriction. So restriction is referring back to our original question. Okay, so that's for our simplifying rational expressions.